We have one more circuit diagram today, that is pneumatic speed control circuit. So here in this board you can see this is the circuit, how it looks. So first of all, going into the subject, so why we are studying this, that is most important. So talking about the pneumatic speed control circuit, so this type of design are basically used in those machines or industries where I need a precise control of movement, right? So that is the basic idea of having this type of systems or this type of diagrams, what we are going to study today. So basically talking about the application of pneumatic speed control circuit, so basically in this circuit what we are going to do is that, since from the name you can say that is pneumatic, so we are using air as the functional part, fine. So since we are using air, so what we are doing is that we are controlling the flow of air, and because since we are controlling the flow of air, so we can directly control the actuated part, the actuation part, fine. So talking about the actuation part, we have a double acting cylinder here. Now talking about the application, let us have an example. We all have seen a drill bit, a vertical drill bit or horizontal drill bit, fine. So talking about a drill bit, so basically we have two types of motion. That is one circular motion, that is where the circular motion is given to the drill bit, and one more motion, that is the linear motion, that is called the feed of the feed, fine, the feed of the drill bit, fine. So talking about the rotational motion, that can be very easily achieved, fine. But talking about the feed, so there is a constant motion that is going downwards. So there is a constant feed that is being provided to the drilling machine, so that the drill bit moves down by a constant number, it is traveling down, fine. So as to achieve that motion, so as to achieve that precise motion, so we need this type of things. One more example, talking about pressing machine. So this type of circuits are also being used where I need a very calm and composed force that is going to come and compress my thing. One more example is that this type of things can also be used for clamping and pressing of tools and workpieces in the workshop, fine. Some other examples are this type of things can also be used in robotic arms, because we are more concerned with the precise motion, how we are going to get the precise motion from this type of circuit, from this type of arrangement, right? So let us look into the diagram, fine. So basically in this section we have a double acting cylinder. So you can see this is a double acting cylinder, and here I have mapped this input line, that is 1 and 2. So talking about this line can be used as input and output based on some of the thing that I can tell you later, right? So this is port 1, this is port 2, but both the ports can be used as input as well as output, depending on what? Depending on this direction proportional valve, right? So this is the valve that can be utilized in such a way that these lines can be swept depending on the input and output line. How? So we can see this is a 4/2 direction proportional valve. So talking about a valve, we know what is a valve, what a valve does, right? So the utilization of a valve is to restrict or to continue the flow of fluid, right? So basically this DCV, it helps us to regulate the flow of fluid by changing the ports, fine. So here you can see we have a compressor. From the compressor, compressed air is being sent through this line, and since we are sending this air through this port 1, so I have an extension of the arm. So this is a plunger, and since I am letting the compressed air pass through this port, so this plunger is being extended, so I have an extension of the plunger, fine. Similarly, so this can be called as input line. Similarly, when the plunger was moving out, right, when there was an extension process, so the air molecules present here was forced to come out through this port, right, because there was a compression of air, and because there was a compression of air, so this port was used as the output port. Now what I can do is that I can switch this part. So what will I do is that I will rub this line, and I'm now going to connect this one here and this one here. So if I connect like this, so even my these connections will be changing, and so this port will come here and this port will come here, fine. So now what we are going to do is that this is a compressor. The compressor is sending the compressed air via this line to this port. Now this is my in, since this is my in, so there is a retraction process. Now I am retracting my arm, fine. So the compressed air is being sent from this line, and now the air molecules here are getting compressed as the plunger is moving inside, inward. And now since the plunger is moving inward and there is a compression of air, the air is getting compressed, it will try to get out of the system, and now it will come through this pod, and via this silencer it will move out to the atmosphere. So depending on how you are moving the DCB, the pods are changing, fine. So these pods can be used as input line as well as the output line. Now talking about the function of DCB, this DCB can be programmed in such a way that I need that, for instant I can have either extension or retraction process, fine. Because talking about this circuit, so we are basically dealing with this type of motion, this type of linear motion. Let's say I have a drill bit connected here. Now the drill bit is giving the rotational motion, the drill bit is given a rotational motion, but what about the longitude, this linear motion for the feed rate, right? So I can have this type of thing so that I can get this type of motion, right? Or let us say that we need to fix something tool, or I need to press something. For pressing or holding some tool, or for clamping of some work pieces, I can use this type of things where I am only interested in this type of motion, this motion. So I can have this motion, shut down the thing, pause the thing, and then it will hold it, and then again I will release, it will retract back, and I'll take the thing back. So I'm more concerned with the plunger, movement of the plunger, this motion, fine. So what we can do now, so there is a problem now. The problem is that in this everything looks good, but what is the problem? The problem is when we are sending the compressed air via this one, so the air will rush so very fast in this pod and try to fill this space, that it will retract so very fast. So always there will be, so you can just imagine, so the air is getting rushed into this cylinder, into this vacant space. Now what will happen, since the air is moving so very fast, so it will have a jerking, fine. Now again I am connecting this port, again I am making all the things. Now I have controlled, I have made programmed in such a way, and I have connected this DCB in such a way that it is continuously switching the sides, switching the ports. Now I am going again having this type of arrangement, right? This type of arrangement, this type of arrangement. Now since this plunger moved inside, I will have this type of arrangement. I will just switch the lever. I will just switch the lever, fine. And because of the switching of the lever, so I will have this type of connection again, where the compressed air will again move inside, fill this space so very fast, so there will so that it moves so very fast, so there is one more jerking. So continuously in a very small given period of time, if I try to switch the thing continuously, what will I have? I'll have this type of motion, and the whole system will have a vibration, fine, because I'm continuously having this type of motion. So this type of motion can't be really used in a real life application, because we are not having any control over the movement, fine. So there is a peculiar type of motion, fine. There will be always a peculiar type of motion, and the time period and everything is not same, fine. So what we can do is that we will be using some of the devices, extra things into the system, so that we can make the thing smooth enough. So how it can be done? We have something called flow control bulb. So along with flow control bulb, what we are going to use, we will be using a non-returning check bulb or bypass bulb. So I will just explain what will be the utilization and how it works. So basically in this line, we will be connecting something that is called flow control bulb, FCB, right? And how it looks like this. So this is a flow control bulb, fine. What will happen in this section is that if I connect this thing here, that means how it is going to look. So let us rub this one, and if I make this one here, this is flow control valve. Now the idea of having flow control valve is that it is used for regulating the flow rate. Actually we are controlling the flow rate, because if we have a hold or control over the flow rate, so what we can do is that we can have the actuation very much in a proper manner, fine, in a very smooth manner, because we are controlling the flow rate of the fluid. So basic idea is to have this thing. So now how it will work is that, now if I want to extend this arm and I am using this port is the inlet port, that is I am sending my compressed air via this line and somehow it is going to pass here, so that I'll get a extension of the arm. Now what will happen, the compressed air is moving in this direction, in this direction, in this direction. Now as soon as it gets here, so there are two directions, either the fluid can move in this direction, either the fluid can move directly in this direction. So there are two junctions that fluid can move. Now the fluid will not move in this direction because this is a check valve. Check valve. How this check valve works? This check valve works in a high pressure region. If the pressure is high here, then only it will work. Now what is the construction? So talking about the check valve, this is the construction, and here I have some spring, and this is how the circuit looks like. Now if there is a fluid line, if the fluid is entering in this direction, if the fluid is entering in this direction, the spring will be compressed much more and this ball will be more rigidly fixed with this part, so it won't allow any gas to pass through this line. But when the fluid moves in this direction, so it will allow the fluid to pass through this line. So this is how a check valve works. So basically this check valve is used for a unidirectional flow, fine. So when there is a flow from the outward direction, then only it will let the air flow through this region, fine. So talking about this part, FCV flow control valve. So the compressed air will come through this line, reach this point. It will try to get through this, but since it is closed, so it can't go through this direction, and it is forced to flow through this direction. Now this part is called metering. Metering, fine. To meter something, to quantify something, to have an account of something, fine. So we are actually metering something, we are actually counting something and sending something, some accountability we have, fine, some hold we have. So what we are holding? We are holding the flow rate, we are having the account of the flow rate, fine. So here this type of thing works in this manner, and the fluid is flowing. So if the fluid is flowing, so it will have a very small lines and it can be easily controlled and it will be pushed very easily, fine, inside this part. So this is called the metering of air. So we are having some control and we are letting the air, letting some known quantity of air into the cylinder, because not known quantity, but we have a very smooth running of air into the system. We are not randomly pushing the air inside this. There is no random pushing of air inside the cylinder. Instead we have a very smooth and proper flow of air inside the cylinder, so that very slowly it moves inside. So this is called metering. We are having a accountability, we are having a constant flow of air into the cylinder, fine. So that this part, this plunger moves very slowly outward, fine. So this is called metering in. Why in? Because for extension this is my inward thing, fine. So this is called meter in. Now as I put this one here, it goes in this direction. Now if the plunger reaches in this position, so this whole area is filled with air and there is a very small amount of air inside this one. So what will I have? I will again switch this part here. So it is, so the decibel will be switched like this. Now since the DCB is switched like this, now what will happen? Fine. Fine. Now since the switch DCB is since the DCB is switched in this manner, now what will happen? Now the compressed air will be flowed through this line and it will try to occupy this part. Since we don't have this type of arrangement here, so very high amount of fluid in a very random manner, in a very chaotic manner will try to fill this space. As soon as the air is moving through this line, so it will have a very peculiar movement and it will try to get to this position, and now we have air inside this one. So what will happen here? Now since we have high pressure air, because this plunger is not trying to compress the air inside this region. Fine. Because here we have a very chaotic movement of air molecules going into this region, so as to fill this part, so as to retract the cylinder, retract the arm. Now what will happen? These air molecules are forced to come out through this section. So now this is output and this is input. So what will happen? This line will follow this part, not via this line but via this check valve or non-returning valve, and it will come out through this part and it will go to the silencer part, to the outer atmosphere. So talking about this part also, in this retraction process also, when the air was moving through from this compressor through this line, even we have a very chaotic and random air moving inside with a very peculiar motion, and it will just try to move in very fast, in a very abnormal manner. Fine. So the movement in this section is not very smooth. But talking about the inlet motion, when we had the extension, for the extension part the movement was so very smooth. So this is the problem, you got the problem. So what we can do is that, so we have some options that is called metering in for extension slash retraction. That is, I can have either meter in for extension, this is metered in, I am metering something inside for extension. So this diagram where I have this portion is metered, I am metering something in, that is inside, for extension, that was I am extending this one. And since we have no connection in this region, so I can't, so this is just for extension. Talking about here, we have written and, so if I put one more this one here, if I have this one, fine. So if I have this one, now talking about the retraction process, what will happen? The compressed air will come here through this line, reach this point. It has two options to move, either through this or either directly through this. So we all know that it is not going to go in this direction, so no chance. So the air will be flowing through this line. So if the air is flowing through this line, so it will be metered, it will be quantified, it will be very smoothly passed through this region. Fine. So very smooth running of air into the cylinder will let the arm move very smoothly. If there is a very smooth movement of the plunger, the air will be coming very smoothly and it will be passing very smoothly through this check valve. If we remove this one, we know that the chaotic motion of air will be filling this inside of the cylinder, and we will have a very non-uniform motion of the cylinder, and because of this non-uniform motion or retraction of this arm, the air will be rushed so very much fast with a very chaotic nature that it will pass through this check valve in a very chaotic manner. Fine. So it will be passing through this check valve in a very chaotic manner, so we will have a very irregular motion, very randomness, very, there will be a jerking every time. So if the rate is fast, if the rate is fast enough, the operative rate is fast enough, so you'll have a jerking every time there is a jerking. Fine. So as to remove that jerking motion, and because of the jerking will have excessive noise, vibration, and ultimately it will let the whole system to fail. The machinery, the whole system will let to fail. So as to remove all this thing, we can have this one. So this is metering in for extension, and talking about metering in for extension as well as retraction, we can have this one. So fine, this is flow control valve, flow control, flow control valve. This is check valve, check valve. Fine. So this is one condition, one what we have. We have one more option, that is meter out for extension and retraction. Fine. So either we can have meter in for extension or meter in for retraction, or both, meter in for extension and retraction. Fine. Pause kar do. So we have looked into the system where how the metering in for extension and metering in for extension as well as retraction works. Fine. So you can see this is meter in for retraction and extension, both are given here. So in this case, both, this arrowhead, always remember this arrowhead is always pointed upward. If it is upward, then we can say it is metering in. So we are metering something, some amount of fluid into the system, and so the arrow is in the upward direction. Fine. So this is metering in, where we have this flow control valve in both the directions, where when we go for extension or retraction, in both the cases we have a very controlled manner of fluid coming and going out of the cylinder, so that we have a very smooth operation of the plunger. Fine. Now similarly, what if we flip the thing and make this pointer pointing upward direction, instead of pointing in the upward direction, why don't we flip it and point it in the downward direction? Then what will happen? So we have one more option, that is called metering out for extension. So whatever we are taking out of the cylinder, why don't we meter that? Why don't we quantify that? Why don't we make that one smooth? So same thing. Fine. So in the upper case, we have metered in some amount of fluid. So we were having the control over the fluid, that which is about to go inside the cylinder. Now we are going to have the control over the fluid which is coming out of the cylinder. So this is the circuit diagram. So if I rub this part, the FCV, flow control valve, so this is a basically pneumatic control circuit, where I have a compressor, silencer, the compressed air is moving inside, so it will continuously fill this entire region. The plunger will move, and then again, if the DCV is actuated, the circuits, the ports will be changed. Then this thing will come outside. It will go. The plunger will go here again for retraction process. The compressed air will be moved through this port. It will be retracted back. This thing, it will be again taken back by the silencer, through the silencer. Fine. So this is the normal one. Now what I did is that I have flipped this part and made this pointed part in the downward direction. Now what will happen if I connect this line here? If I connect this line here, then what will happen? So we are not in advance telling that this is metering out for extension or retraction or both or anything. We are just looking into the diagram and telling what it is. Fine. So this is the normal condition. Compressed air is flowing through this through this line. It is moving. It will move in this region. After moving in this region, now it has two paths. Either it can move in this direction, or it can move in this direction. Now since we have arrowhead in this direction, this is the point through which the fluid can pass through this check valve, because this is high pressure region. The compressed air is coming, so it is HP, high pressure region. So this port will be opened up and it will let the fluid pass through this region. Fine. So what will happen? It will not go in this direction, but it is going to flow in this direction. So compressed air are forced to pass through this non-returning check valve, and it will pass through this in this region. So as soon as it is passed in this region, fine, so it is a high velocity of air, high pressure air is flowing inside this one, so plunger will again move in this direction, and the amount of air in this region will be pumped out through this part, and it will flow through the silencer. Now if we talk about this situation, so this here we are going for extension. In the extension process we are not going to get any smooth operation, because it is passing through this check valve, it is moving it is extending, and the amount of air present here is coming out normally, so nothing is being metered in or metered out, so there is no metering of anything, where there is no metering at all. Fine, so we are going to get nothing, we will get a absurd motion, very peculiar type of plunger movement we are going to get. Now if I connect this part in this direction, so talking about metering in or metering out, so we say that in the first case when we are when we were moving the air, so we are getting this, so the extension is not proper. Fine, now what we can do is that we are going to connect this one here, and we are going to connect this here. Fine, now this is called the retraction process. Now if I actuate this DCB, then what will happen, I am retracting the plunger. Now the compressed air are forced to pass through this line, and it is now in a very chaotic manner, in a very fast manner, in a very jumbled up manner, all the air molecules will come through this line and try to fill this space. As this space is being filled, the air here will get compressed. Now as the air is getting compressed, what will happen, it will try here, it will come here, and now it has two paths, either it can go in this direction, or either can directly it can move through this part. We all know that the air will not move through this part because it will be closed, so no movement of air through this check valve. All the compressed high pressure air will be moving in this one. So what is happening is that we are metering out in terms of retraction. So this can be called metering out while retraction. Metering out while retraction. Fine. When we were retracting back, the air molecules present here was forced to pass through this line and is coming out through this silencer. As it is metering out very smoothly, very politely, very gently, in a very normal manner, in a very good pattern, the air molecules are going to leave this spot in a very super fine manner, so that I have a very precise control movement of the plunger, which is retracting back. Fine. So this is metering out. We are metering out some volume of air in such a manner while retraction that we get a very smooth operation. Fine. Similarly, what we can have here in the both cases we can have. Fine. So and also we can have here one. Just like in above case we had in both the cases, here also we can have in both the cases. So if we have for both the cases, then what we'll call metering out for or while extension and retraction. So for both the cases we are metering out, so that we get a proper flow of air, because here only in case of retraction we are getting a very smooth operation, but in case of extension we are not getting smooth. So as to have a very smooth operation for retraction and extension, we should have in both the places, just like this case, in both the places we are putting FCV, flow control valve. Fine. So again, the compressed air is coming in this direction, it will go. So since it is moving very high pressure fluid, so it will flow this direction, in this direction. So this is how it is going to flow. This is how it is going to flow. This is how it is going to flow. Fine. Since it is moving, so even in this portion also it will be moving in a very chaotic manner. So it will try to go very fast. It will have a tendency of going very fast, because a huge amount of high pressure air is moving through this check valve and try to fill this space. But because we have here air molecules inside this region, so this is again HP, because this air present in this chamber will try to push this plunger, they will have a tendency of pushing this plunger towards this side, so that this air molecules here will be compressed. And since we have a very high pressure region here, so chances of air moving through this one is less. Fine. So what will happen, most of the airs will pass through this line. So what we are doing is that we are metering out. Fine. While extension metering out, fine. So while extension, this air is being metered out and it is sent via the silencer to the atmosphere. And again, for the reversed case, when we connect this line here and here and here and here, again same thing is happening, this thing is happening, the retraction process is taking place. So when we try to get, when we plan to get a very good motion of the plunger for both the cases, so we can have these two things. Fine. So that's all for the pneumatic speed control circuit. In the later part, we will be seeing in the automation studio. We'll try to simulate this part in automation studio. Fine. So this is the explanation, and this is the circuit diagram and all the parts. This is a double acting cylinder, this is a directional control valve, this is a flow control valve, this is a silencer compressor. Fine. So all these things are here. So that's all for this part. Thank you. Okay, so here is the simulation for the metering in while extension and metering out while retraction. So first of all, we are going to look after the metering in while extension. So for that we'll take some of the things, like for example we need this pressure relief valve. So we'll just drag and drop. We need a hydraulic reservoir. Since we are doing pneumatic, so we can also have gas loaded accumulator or something, cylinders filled with gas. So we have these things, gas loaded accumulator we have here. So let's say, like, for simplicity we can take the reservoir. Fine. Then we can have filter we can take. Then we have this throttle valve. So most probably I will be taking from here some of the things. So this is DCV, so let us take 4x2 DCV here. Also we need this one, variable non-returning throttle valve. So this is the throttling part of the fluid. Fine. So this is the main component we have here. And then we have actuators. In the actuators, yeah, so double acting cylinder. Fine. And we will be needing a pump, so we'll take a fixed displacement pump. Fine. So first of all we'll rearrange these things. So first of all we have this reservoir, so we'll be connecting this one. Fine. Start. Okay, so let us zoom here, and then we have this one. So let us rearrange first of all these things. We'll take it down. Fine. Fixed displacement pump here, and before the pump we have a filter. Fine. Fine. So the reservoir, filters and pumps are connected. Then we have this pressure relief valve, so we'll connecting this one, and from the pump we have this thing, so we will be connecting this one in so that the fluid goes inside here. And this one is the return port or the return line. The fluid will be returning from this port, the cross, in the downward direction. So we will be connecting this one to the reservoir, and so that it gets accumulated in the reservoir. And then we are going to do here some of the changes. For example, if the arrowhead is pointing downward, then we are metering out something, and that will do in case of retraction. Fine. Now we are going for metering in, that is we are giving input into the cylinder via metering the fluid. Fine. So for that we will be, what we will do, will make this part, the arrows in the upward direction. So we'll click here, and then we have this edit option, we have this position, so change it little bit. Fine. So this arrows and the check valve arrow is in the upward direction, so you can see this is the upward arrow, and also this one is the upward arrow, so that the fluid can go inside here. And once the fluid reaches here, so it has two paths. It can go either this direction, in this direction. So it will go through this direction, because we all know that this is the check valve, and it will be loaded with the pressure so that the fluid does not come out of the system. Fine. So the fluid will be stopped there, so the fluid will be forced to pass through this throttling valve. Fine. So we will be connecting this one like this, and this one to the in, and we have this one to the out. And we'll go in the simulation tab, and we'll do the normal simulation, and the normal simulation will go for this in. So you can see there is an extension, and there is very little extension. Fine. Very precise movement of the cylinder, and the cylinder is moving out. Fine. So there is an extension in metering in. Fine. Okay, so here you can see the finally the cylinder reached its extreme position. Fine. And again for retraction I can have this one, so you can see the retraction is so very fast, but the extension is very little. Fine. Because here we don't have, in this section we don't have anything, we are not metering this thing out. Fine. So while we are sending the fluid, and when there is an extension, so there will be very minute extension, very precise movement, very slow movement of the cylinder and the plunger. But then when I retract back, so you can see it is so very fast. So I can have here in the opposite direction, so that the metering is done in both the lines, the input line and the output line, so that whenever I go for retraction or extension, there is a precise movement of the plunger. Fine. So let us stop this simulation, and we'll be adding here in the opposite direction this one. Fine. So what we'll do is that we'll now just copy this one, paste it here, delete this line, and we are going to add this here. Fine. So what will happen now, if the fluid is taken from this direction and it is passed through here, so while retraction it will be metered. Fine. And then it will move in a very precise position. Fine. But while returning, when it will be returning, so fluid won't able to pass through this line, so it will be forced to pass through this bypass. But while going, so it will be blocked here through this bypass, and it will be forced to pass through this throttle valve. Fine. So we will be connecting this line here and this line here, and normal simulation. So first of all in, so while in, you can see it is going very precisely, very smoothly. Even I can change the pressures also here, so the displacement can be increased or decreased. Fine. And if I go here, and also I can set the cranking pressure. Fine. So if I crank it to something very less, let's say this one, and if I go for this one, so you can see, so first of all it was going so very fast, but then since we are metering some fluid from this port as well, from the port 2 as well. Fine. From the output port, so you can see, and here in this section you can see the fluid which is coming, it is passing through this bypass check valve. So it is opened now, this one is closed now. So it is open, so it is passing through this portion, it is coming out through the and going back to the reservoir, fine. But in this case, this one is closed, this one is opened, so it is going and it is filling this area, the plunger is retracting back, fine. So that's all for the video, fine. Thank you.